Okay, in this problem we're asked to find the voltage V0. We have magnetically coupled inductors, so we're going to use our problem solving strategy entitled magnetically coupled inductors. And the first step is to define mesh currents. So let's define mesh currents on our circuit. I'm going to define this one as I1, I2, and I3. So we have three mesh currents, so that means we're going to have three equations. And if we notice in our circuit, we have a current source, so that means a constraint equation. So our constraint equation is I2 minus I1 equal 3 at an angle of 10 degrees. Okay, so there's our first equation. Now, we need to apply KVL. So for instance, let's apply KVL to this mesh. We can't apply it to either one of these, but what we can do is we can apply KVL to this loop. So let's start with this mesh. So if we start up here and go around clockwise, we'll have 4I3, the drop across that resistor, and as we come around we'll have minus J1 I3 plus 10 at an angle of 0. And as we come on around, we'll have a term 2 plus J2 times I3 minus I2, and that's because I3 minus I2 flows through those two impedances. Now, we have the coupled inductor, and we have two voltage terms. First, we have one due to current I3. That's going to be polarized like that, and that's going to be plus J3 I3. And now we have another voltage term due to current flowing on the other side of the coupled inductor. So if we look, current I2 enters the dot, so it produces a voltage in the other coil like that. Note that that term is the opposite polarity of this, so then we have a minus J1 I2 equal to 0. So if we simplify this equation, we'll come out with minus 2 minus J3 times I2 plus 6 plus J4 I3 equal to minus 10. Okay, so here's our second equation. Here's our first equation. Now, we need to now go around this loop. We'll start here. Okay, so we'll have 2I1. Coming on around, we'll have 4I2. Okay, now we're at the coupled inductor. So we have two terms. One is just due to current I2 flowing. Okay, and that's the voltage like that. So that's J3 I2. Then we have another voltage term. Current enters the undotted terminal over here, so it's going to produce a voltage plus to minus with the plus on the bottom. So we're going to get a term that's minus J1 times I3. And as we come on around, we'll have 2 plus J2 times I2 minus I3. And as we come on around, we'll have a J3 I1. That's for this term. And that's equal to 20 at an angle of 30. Now, if we simplify that equation, it'll become 2 plus J3 I1 plus 6 plus J5 I2 plus minus 2 minus J3 I3 equal 20 at an angle of 30. And if we put those in matrix form, for solution by MATLAB. Here's what we'll have. So here's our equations in matrix form. Okay, solving using MATLAB. And we only need I3. I3 is minus 0.0665 plus J 1.3968. And if we look back at our circuit, we can see that V0 is the voltage across this element and this element. So it'll be minus J1 times I3 plus 10. So V0 minus J1 times I3 plus 10. And V0 turns out to be 11.4 at an angle of 0.334 degrees volts.